Okay, so I'm going to show you how to use LinFIR to shape the response of a four-way system with linear-phase FIR crossovers. First, we set the sampling frequency and the number of taps for our DSP. Here we will use Hypex plate amplifiers. Then, we import some previously measured impulse responses. In this window, we can apply time windowing to remove reflections, in case your measurement conditions weren't perfectly anechoic. Now let's shape the individual frequency responses of each driver, starting with the subwoofer. In the IR configuration window, you can automatically generate a list of filters to flatten the response. Just set the limit parameters and the maximum number of filters, then click Generate. You can still manually adjust the generated filters afterward. Now we activate the FIR low-pass filter. By default, the crossover frequencies are set to 120, 600, and 4000 Hz. Once we're happy with the subwoofer's response, we move on to the mid-bass driver and repeat the equalization process. The gain and time delay parameters let you align your drivers in time and level, without endless trial and error or remeasuring every time. You can directly visualize the theoretical result and apply those values to your DSP. The Configure button next to the FIR filter lets you fine-tune its parameters. You can set the filter type, cutoff frequency, windowing, and causality. We'll talk more about causality in another video. For now, we'll leave it as is, to keep a linear phase crossover. Let's move on to the upper mid-range driver. The step and impulse response previews can help you time-align the driver, along with the magnitude response in the crossover region. See how both change when we adjust the time delay. The group delay of our mid-range is a bit messy, but we can fix that. When you open the FIR correction filter configuration, you have access to both magnitude and phase correction. We won't use magnitude correction this time. The corrections can be computed either before or after applying the IR filters. See how the phase correction flattens the group delay and reshapes the impulse and step responses. You can even invert the filter polarity to keep the main peak positive. And finally, let's work on the tweeter. Let's disable curve smoothing to reveal the ripples caused by box diffraction. Here, we set the automatic IR filter generation to avoid high Q filters. The tweeter also needs to be time-aligned, so let's do that. The impulse response now looks quite clean. But we can still improve the magnitude response. We'll use the EQ of the mid-bass driver to compensate for this dip caused by a port resonance. The first EQ filter of the subwoofer is a bit too aggressive, so let's reduce its gain in Q. Now, let's take a look at the filter responses. Each FIR filter added to a driver's signal chain is convolved into a single one, simplifying DSP implementation and saving taps. Here, you can see the FIR responses. Remember how we corrected the phase of the mid-range? In the group delay graph of the FIR filters, you can clearly see the correction applied. The other filters are purely linear phase, so their group delays remain flat. You can also visualize the IR responses, and the combined IR plus FIR response for each driver. Once you're satisfied with the overall result, you can export your FIR coefficients in the format of your choice. You can also export a full report, in text or PDF, listing all the parameters that can be directly imported into DSPs, IR filters, gain, delays, and so on.